Hey guys, today we're going to talk about the unit circle. And this topic is a bit complicated, so don't worry too much if you don't get it at first. But I'm going to try and explain it in the most intuitive way possible. Okay, so what the unit circle is it's a circle with a radius of 1. So this length here would be 1. Same way, this length here, this length here, this length here would all be 1. So if you put the circle on a graph, for example, you would get this point, which is on the x-axis, as 1, 0, because remember, this is a radius, and the value is 1. This one would be 0, negative 1. This value would be negative 1, 0, and that would be 0, 1. Okay, so that's just to help you visualize what this looks like on a graph. Okay, so what we can do with the unit circle is, well, if I draw this, if you look at this triangle here, it's a right angle triangle because these are two straight lines. And if I draw an angle here called theta, okay, so how do we find this yellow length and this blue length in terms of theta? Well, if we just call this yellow length x and this blue length y, the way we can find in terms of theta, and I'm going to tell you why we do that in a second, but I just want to show you how to do it first, because I don't want to make this too complicated right at the beginning. But the way we can find this in theta is, well, we know the cos of any angle is the adjacent over hypotenuse. And the adjacent and hypotenuse of adjacent side and hypotenuse of this angle is, well, the adjacent is just x, and the hypotenuse is 1. So we get x over 1, and x over 1 just equals x. So cos of theta equals x. Okay, so that's pretty simple. What about y? Well, y is opposite theta, and we know the sine of any angle is the opposite over hypotenuse. So the opposite will be y, and the hypotenuse is 1, which again is equals y. So sine of theta equals, sorry, no, 1, y. Okay, so this equals sine theta. So now we have x and y in terms of theta. What can we do with that? Well, we can find this point here. Okay, that point, hopefully, you can understand that that point will be cos theta sine theta. And the reason for that is, remember, this is the x value and this is the y value. So again, it's on a graph. Don't forget that this is all a graph. This is the x-axis and this y-axis. So this point here would be cos theta sine theta, okay? Okay, so that's pretty simple. But what if I drew, let's say, a line here, okay? And again, remember this value is 1. And this angle is also theta, so that's the exact same angle. I'm gonna draw, so therefore, this blue value and this yellow value will be the same. So x and y, or we can actually write that in terms of theta now. So cos theta and sine theta. So if I drew that, well, first of all, we know that angles in a straight line equal 180. Okay, so that's pretty simple. We know that. So what that means is, if both these angles are theta, we know that if I wanted to find this angle from this point to this point, okay, that angle would just be 180 minus theta. So the reason for that is, well, you're just taking the full 180 angle and minusing this theta angle, okay? That's not too difficult. Okay, so if you understand that, you shouldn't struggle too much with this next part. Okay, so actually I'm gonna keep that. Okay, so we know that angle now, that's 180 minus theta. Another thing we should know is that how do we find this point? Well, you may think, well, these triangles are exactly the same, so it would just be the same as this point, cos theta sine theta. But remember, this is still a graph, so it would be actually negative cos theta sine theta, because in this quadrant, the x values are negative. Remember, so this length is cos theta. The length, which obviously can't be negative, is cos theta, but the point is negative cos theta, and the sign is still, well, the y value is still positive. Okay, great. So now if I extend another line down here, again with the same angle relative to the x-axis. We always draw the angle to the x-axis. Don't ever draw the angle here. That's a mistake some students make, but don't do that. Just draw to the x-axis because we want to keep everything the same. So again, this blue line will be there with the same value sine theta, cos theta. I'm not going to write it down because you guys should know that by now. Okay, so what we're doing essentially is we're extending this red angle further down here. Okay, so now what would the value of this red angle be? I'm gonna explain why we're finding this in the first place in a second. So what would the value of the red angle be? Well, it would be now 180 plus theta. Because remember, it's just this 180 plus this theta. So 180 plus theta. That's the red angle. Okay? I'm gonna rub that out because I don't wanna leave too much on this one. I'm trying to keep it as simple as possible. Okay, so again, that means you can find this point here. Hopefully you can guess that this will be negative cos theta, negative sine theta, because remember, both x and y are negative in this quadrant. Okay, and again, if we extend, if we extend one last time here, same blue line, same angle, there. It's not a great line, but just ignore that. Okay, so this point here, again, hopefully by now you can recognize, would just be cos theta negative sine theta. And if you extended this red angle all the way here, hopefully you understand that that would be 360 minus theta. And the reason for that is, well, remember, angles in the whole circle, like this angle here would be 360. So if I took that whole circle, but I minused this part here, which would give us this red angle here, I'll get 360 minus theta. Okay. So what can we do with this, with these values? Well, we can find a few rules. Okay, so the rules we have found from the unit circle so far is, well, the cos of an angle is the x-coordinate and the sine of an angle is the y-coordinate. Okay, so what we can do with that is, well, if we look at this red angle here, which we found earlier is 180 minus theta. So if we took cos of 180 minus theta, okay, we know that the cosine of an angle is the x-coordinate, and the x-coordinate is here, negative cosine theta. So what we get from that is cosine of 180 minus theta equals negative cos of theta. Okay, again, that might be difficult to understand. You can go back and rewatch it. But that is the rule. Okay, so I did spend a couple of minutes before explaining why that's the rule. But if you just want to boil it down to I just want to know the rule and you just want to get the marks, well, that's the rule you need to know. Okay, I just think it's more helpful to understand why the rule is what it is, because it'll help you answer harder questions if you ever need to apply understanding instead of just memorizing the rule. Okay, so if I extended this angle down here, we know that that angle is 180 plus theta. So if I took cos of 180 plus theta, what's the x-coordinate? Well, it's still negative cos theta. So I get negative cos theta, okay? So cos of 180 minus theta and cos of 180 plus theta is negative cos theta. So another rule you can get is cos of 180 minus theta is equal to cos of 180 plus theta. Okay, those are three rules. Again, if I extend this a bit more, we can see, again, this angle we know is 360 minus theta. So cos of 360 minus theta equals cos of theta, because the x-coordinate here is cos theta. Those are the cos rules. Okay, now we can do the exact same thing, but for sine. Okay, if I take this angle here, just focusing on this angle, the pink one, we know that's 180 minus theta. So sine of 180 minus theta equals the y value, which is sine theta. Okay, great. Now if I extend that further down here, sine of 180 plus theta, I'll get negative sine theta. Okay, and then great, if I look at this angle here, sine of 360 minus theta will give me negative sine theta. So again, I can take sine of 180 plus theta equals sine of 360 minus theta. Okay, so there's 4 more rules you get from the unit circle. And what we're going to do next is learn how to apply these rules to solve questions. Okay, now we're going to solve some questions. So if I had, well, I'm just going to draw this first. If I had a question that said find sine of 150. Okay, it's a very, very easy question. If it was in a non-calc paper, probably maybe 2 marks. I've honestly never really seen a question like this because it's a bit too easy. But you know from our rules that we learned in the last bit, it's just sine of 180 minus 30, which equals sine 30. And if you don't know, that's 1/2. If you haven't seen our last video on the triangles, you should definitely go watch that. So if you have a 60, 30, 90 triangle, this side will be 1, this will be root 3, and this will be 2. So if you take sine of 30, opposite of hypotenuse, you just get 1/2. So you definitely go watch the video if you haven't seen it. I would say it's crucial for trigonometry. Okay, so that's very easy to do even without the unit circle, but I'm going to show you how to do it with the unit circle because it's very rare they'd give you a question like that. Okay, so let's say you have to find cos of 150 and sine of 150 using the unit circle. Well, that would just be, you can draw 30 here, 30 here, 30 here, and 30 here. Okay, you know what this point's going to be. It's going to be cos of 30, which is root 3 over 2. You can find that using the triangles, and sine of 30, which is 1/2. This will be negative root 3 over 2, or 1/2. And this will be negative root 3 over 2, negative 1/2. And this will just be root 3 over 2, negative 1/2. Okay, so cos of 150, pretty easy. Just this angle here, 180 minus 30, just this value. Negative root 3 over 2, sine of 150, we know that already, 1/2. Okay, so what if I said cos of 180? What would that be? Well, that would be, if we extended this angle down to here, what's the x-coordinate at this point? Well, we know the radius is 1, so the value would just be -1. Another way, so there's actually 2 ways you can do this, 2 ways you can do any of these questions. The other way is memorizing the graph of cos, and I think this is a bit harder to do than the unit circle. I mean, it might be easier for values like cos of 180, but I definitely think finding cos of 150 using the graph is, I don't think you should do that. It's much more complicated. But if you do draw the graph cos for actually no, I'll draw it up to here. If you draw it for 360 degrees, that would be 360. You can think of it this way. So this angle here is 90, okay? So after 90 degrees, cos reaches 0. After another 90 degrees, it reaches -1. So, by the way, this is the y value, sorry, not the x value. Don't want to confuse you. The x value over here would be 90 because it's 90 degrees. And over here would be 180 because it's 90 plus 90, which is 180. So cos of 180 would equal -1. That's just a way of looking at it on the graph. For 180, yeah, you could definitely use the graph, but if I ask you something like sine of 150 or cos of 150, you should definitely use the unit circle. Okay, so if I asked you cos of 210. That would just be extending it down to here, which would give you the x-coordinate is negative root 3 over 2. Okay, so the last two things I want to do is, well, if I asked you cos of negative 150 degrees, how would you solve that? Okay, so this whole time we've been going in the anti-clockwise direction whenever we're looking for angles. So if I ask you cos of 150, well, you'd go there, okay? But now well, actually I should draw, these are 30s. Okay, so now we're looking for negative 150, so we're gonna go in the anti-clockwise direction. So we know this, well, first of all, this is 180. Okay, we know that, angles in a straight line. So 180 minus 30 would be 150, and 180 minus 30 will just be going here, there. So that would be negative 150. Another way you can think of it is, well, this is 30. So if I do one more line here, I would get 60. One more line would lead me to 90. One more line would lead me to 120, and one more line to 150. So that's how you get to cos of 150. It's just this line here. It's the same thing as the top, but in the negative direction. Okay, so that's 150, and the value of cos of negative 150 would be the x value here, which would be negative root 3 over 2. Well, the coordinate would be negative root 3 over 2 and negative a half, because remember, this is cos of 30. So cos of negative 150 equals negative root 3 over 2. Sine of negative 150 would equal negative a half. Okay, that's not too hard. Okay, and the last thing I want to do is, well, if I ask you cos of 405, how would you solve that? Okay, so these type of questions are the main reason we learn about the unit circle, because you pretty much need the unit circle to solve this. I mean, it's very, very difficult to solve without the unit circle. You could use the graph, but I think the unit circle is definitely the best way to solve it. So when we look at 405, we can simplify that to 360 plus 45. So this is what you want to do with any large angle you get. You want to try and get as many 360 as you can. So for example, if I had 870, it would be, well, you can go 360 goes into 870 twice. So 360 times 2 equals 720. And 870 minus 720 equals 150. So cos of 870 would just equal cos of 720 plus 150. Okay, which is just 360 plus 260 plus 150. Okay, so that's what you want to try and do when you get a large angle. You want to simplify it into a value of 360 plus another value. So cos of 360 plus 45 makes it a bit simpler. And that's because, well, if I take 360, that's just one whole revolution. Okay, so you end up right back at the beginning. And then if you want to get to 405, you just add one more 45 degrees. One more 45. So cos of 360 plus 45, or cos of 405, just equals cos of 45. And remember, if we look at our rules here, we found cos of 360 minus theta equals cos of theta. Well, that's also equal to cos of 360 plus theta. Okay, so cos of 405 equals cos of 45. Cos of 45 just equals 1/2. Okay, I'm gonna do one more example. If I wanted sine of 870, well, we did this earlier. It would just equal sine of 360 plus 360 plus 150, because 870 equals 360 times 2 plus 150. Okay, so how would we find that? Well, it's just 2 revolutions plus 30 degrees. Sorry, not 30, plus 150 degrees. Okay, so plus 150. What's the y coordinate at this point? It's just 1/2. So sine of 870 equals 1/2. Okay, that's the unit circle. I know it was a long video, it's a bit complicated, but I feel like if you can get this down, it'll be a lot easier to understand the cast diagram, which is definitely essential for hard trig questions. But yeah, I do understand it's complicated. It may take you a few tries to get it, but I think it's really necessary to understand.